All right. Okay. So, guys, eventually, our goal is to get you to understand inverses and how to find the restricted domains of inverses. So that just a regular function, you guys are having trouble with identifying what the domain and range were. Domain is all the stuff that goes in, which a student was telling me how someone was explaining you're at the vending machine and the X is the range, it's the number, it's the buttons you can push. So the domain is the buttons you can push, and the Y's, snacks you get out. It's like inputs and outputs. You put in the money and push the buttons, and out comes the snacks. It didn't really work for me, but he was really excited because it involved snacks. And he felt he understood the inputs and the outputs better. You put in button pushes, and you got out chips. Or chocolate, depending on if you're in a salty mood. Okay. But so our end goal, we need to put together all these things. Composition of functions, that's the f of g of x business, and restrictions on them. And part of it, we need this stuff too. This is Algebra 1 geometry and Algebra 2. I asked earlier classes, like, when do you remember learning this? And some people remember it from Algebra 1, some said geometry, a lot of kids said Algebra 2. But key thing is, everybody said they did it. Not that they remembered it, but that they did it. So, question. What does that minus 1 do to the parent function of x squared?
Doesn't it move it left and right?
Which way, how much does this move and which way?
Right one? And
Moves
then up,
right 1 and
up 6.
up 6. Okay? So there's my friendly regular parabola, my quadratic. This guy, over 1, up 6. So having an understanding of what the transformations are, I don't need to go plug in all these numbers and do a lot of math. I can just be like, all right, the vertex moved over 1, up 6, draw the U shape from there. And you guys know this f of x, that g of x, h of x, it's a function name. Do you know it's also the y value?
Yeah.
Like you're okay with that? So trying to explain, so Maya said y went up 6, because y was a positive 6. But Sophia said that guy moved 1 to the positive, the way that I, like, because it seems opposite, but y equals up 6, x equals move over 1. Like, if you set that thing equal to 0 and solve for the x, you'll get the shift correct. Okay? Or maybe it's only me that does this backwards, but I just like that it seems different. Adeline, what does this negative 5 do? Moves it down 5. Joseph, any idea what that 2 does?
Like the amplitude.
No? Dante's saying amplitude. I don't really have an amplitude on lines.
Dilation.
Dilation, which way? This way or this way?
Horizontally.
Horizontally? So, does it make it fatter? Or does it, Eileen's making wrinkle face there. Okay, if you think about it, if it's just y equals x squared and then I multiply that by 2, that to me means the height is getting double the height each time, so it's a vertical stretch. So it means that parabola is going to be a little skinnier. Antoinette, what does this 3 do?
it would usually be like this, but now it flips it down. So it's, it reflects downwards.
Okay, fancy words. All the positive y values are now negative, so she's saying it reflects over the y-axis, yes.
I forgot when it would be like a horizontal stretch, like where in the equation would it like show that? If there were a horizontal one. Oh. Kinda.
So, speaking of that, we'll look at that in just a second. All right, so what's coming up? Your homework tonight is page 39 in your packet. What kind of things can be on the second quiz that's on Friday? What have we done since page 13 in the packet? Nora? It hasn't even been? Okay, bring it up. What do we got?
Even and odd, and then there was this other one.
Even and odd, and then there was this
Composition
other-
of functions. Domain of composition function. And then I don't know if there's more. But probably is.
Today. This transformation business can be on there. So she just said domain of composition of functions. Yeah, and that one can be stinker. To give you an example. Am I allowed to put any number into f of x? Angel, what do you think? Here's f of x is x squared plus 3. Can I square any number and then add 3 to it? No? So what number can I not square? Okay. I can do this with any number at all. Okay, yeah,
Oh, so it's gonna flip.
okay.
You can't have a zero in the denominator, so the domain is gonna be 0 to infinity. Oh, wait, no, it gets negative infinity to 0, union 0 to infinity.
Perfect. Okay, so g of x can't put in 0.
You're right here.
F of x, anybody works. If I need to combine them, g of f of x. And this is Nora's fault, because she was like, yeah, we did that. Do y'all remember?
Yeah.
Okay, Dora, how do I find g of f of x? Do one tiny piece.
G of f of x.
What do I get rid of first? Just get rid of one thing.
You get rid of the. Yeah.
Yeah,
The the f of x.
and this is not gonna bring out what I wanted to say. Okay, g of f of x. Okay, what's g of that now? G of that,
Okay,
so this is exactly the thing I didn't wanna do, like, now, I can still put in anything, cause is this denominator ever gonna be 0? No, so,
If it was 9, it could be 0, but.
no, like, no, 9 squared is 81 plus 3 is 84,
Oh.
it's not a problem.
Okay.
Alright, this is why I don't make problems up off the top of my head.
so this doesn't work?
Well, it doesn't bring out the point that I wanted to say.
Okay.
So I'm gonna get rid of that squared because that ruined everything for me. So getting rid of the squared, now is there some number that I cannot plug in? So now the composition of functions, g of x originally said can't have 0. But when I combine them together, I got this, and now it's actually x is not allowed to be negative 3.
So you always take the domain of the inside function first.
Well, domain of the inside function was everybody.
I know, but if it doesn't work for your inside function, then it doesn't work at all.
Oh, okay. So here we just did g of f of x. Grace asking f of g of x, which is f of 1 over x, which would be 1 over x plus 3. That, we weren't allowed to put in 0 in the first place? Yeah. So those of you who were in class, remember this was like if f of x, I'm in DC going to Europe, and I have a transfer to New York. In DC, they're like, do you have a ticket to Europe? Yes, I do. Then in New York, they say, do you have your passport? I do not have my passport, I am stranded there. Versus this one is saying, do you have a ticket?
See if they keep the one.
No. Well, then you don't need to go to Europe, you don't even get on the plane. You're stuck. Okay, that's kind of a recap of stuff. Can you guys look in your packet and see if those transformations are fresh enough in your mind? The next
So,
two,
alright, so if
what does that 4 do in each case? What does the negative do in each case?
then do like x,
Yes,
one over x, right? Yep. And then you go into, you're replacing this, right, with this x. That's one over You're replacing this.
Any number that doesn't have is in an X, just keep it.
I'm so cooked, but
So cooked.
Wait, you see number 1 is,
Number 1. I think so, 'cause it's like negative, like.
that's a flat.
I actually don't know, to be honest. That's what I thought too. I think it's
Can anyone put up the answers? Confident enough to put up all of them? Yes, no? Yeah, do it.
I think
Gotta do all of them, Teddy.
I think 3 is E.
Yes.
And then C is A. Oh, okay. Oh, good job.
No, number 4, let's see. My mom is actually the greatest individual ever bred.
You're saying H is
Well,
in case people put the numbers.
I'm not.
E
Yeah.
is 2, you said 3, E, or 4 is D, 5 is A, 6 is G, F is 7, and C is 8. Do you guys agree?
Yeah.
Oh, Nairo? Do you agree?
Yeah.
He just told. It actually has to take off right, so.
Chocolate?
Yeah, I heard it. Okay. As third and fourth period realized today, I'm not above driving. Okay. So, guys, if you disagree with any of these answers, ask. Like, because I do have chocolate. Much, much less than earlier today.
Oh, I'm back.
So, that 4 moves the whole function left 4 units. This -4 moves the whole function down 4 units. This 4 on the outside made it 4 times taller. Right here, it got tall. Similar to this one, but that one was only 2 times taller. Why 2? Well, the square root of 4 is 2. That -4 shifted the whole thing to the right, over here. This negative reflects it over the x-axis, which puts it here. Moves everybody up, up. Reflects over the x-axis, that's this guy. Okay? You guys are right with that? Everything's all good? Bella, you good?
Yeah.
Raul? Okay. Now the thing I didn't wanna do. Inverses, we need to know how to undo something. Like, you guys working on computer programs, how do you undo on most applications? If you wanna undo, Control Z. So, we wanna find Control Z, how to undo for any operation. If I put in your student ID, I want your name to pop out. Is it okay if I put in her student ID, 1, 2, 3, 4, 5, 6, and I got 8 names back?
No.
That's not okay. So an inverse, for an inverse to be a clean, I'll call it clean inverse, I put in one ID, I get one person out. If I put one person's name in, you should not have
8
multiple, yeah, you should not have multiple ID numbers. Okay, so. If I put in -5, when I square that, now see, what do I get when I square -5? Positive 25.
Yeah.
It's still
Okay, so,
because of that.
okay, so what is the inverse of squared? If you were solving something and I told you x squared is 25, what is x? How do
Square root it.
we do square root? And you would have to remember, you'd have to know, well, it's +5, oh, it could also have been -5. So the inverse is not clean, I had 2 possible answers. Okay. So inverse is just how to undo stuff and just notationally. You guys remember, we did that this year a little bit, we did some inverses.
Yeah.
Okay, we traded the x and the y and we solved for the f inverse for a couple of things.
Did we do that with the summer homework?
It should have been some on the summer homework as well. But I thought there were a few pages in the packet, but I've done more of the packet, but I'm confusing myself. I thought we did it, but maybe not. We're getting there then. Okay. Well, one of the things to be able to have what I'm calling a clean inverse is the function needs to be 1-to-1. Put in a single ID, get out a single student name. Put in a single student name, get out a single ID. Can anyone, looking at these, can you guess which of these are 1-to-1? Do you have any idea, Greg?
Well, there's the vertical line test that you use for.
Okay, vertical line test is to see if it's a function.
Oh, sorry, the horizontal line test. My bad.
So vertical line test,
Yeah, my bad. And then.
all of those pass the vertical line
test,
test.
it should only, if it's 1-to-1, it should only hit at 1 point,
Okay,
like throughout the graph.
Alright, so if it's a function, it needs to pass the vertical line test. Do you guys understand what Ray was saying about that? That I drew all these vertical lines and it only hit the function once. And then he said, to be one-to-one, it needs to pass the horizontal line test too. Which that is, if I draw a horizontal line, I should only hit the function once. So is that first function, that parabola, is it one-to-one?
Yes, it
Drawing the horizontal line, I only hit the U shape once?
is. Wait, no.
No.
Maybe twice.
I hit it twice in a bunch of places. So it's not one-to-one. What about this one? Okay. It is also one-to-one. Third period was not happy with it either. They're like, well, how can I tell that this curvy bit here? And you're right, visually it's hard to tell, but it is also one-to-one. What about the straight line? Come on, what do you think?
Quick question.
Yep.
So the reason why the second one is one-to-one is because it hits both lines together.
I mean, yes, whenever I put a vertical line, or sorry, horizontal, it only touched it once. Come on, what about the last one? Does it pass? Does this horizontal line cross the line twice?
No.
no.
Right, so it is one-to-one. Okay? So, down there, which of those are one-to-one and which ones are not? Which ones are gonna have a clean inverse, circle or
First one and C are gonna have not one.
First one and the third one are not.
What do you think, Virginia? B and D, the two on the right?
I think that's just B.
Wait, so
What do you think, Stuart? Do you agree?
I think that's
She said,
She's clear, I thought she left.
the one-to-one functions, she said, are these guys. Do you agree?
if you do it like this, is it, or if you just do it like this, like that.
Just show it to me.
That's your response, what do you
I
have?
don't know, cause on B, it's like this weird line here. It's made me think it
Well,
was
no,
like
because
this.
then you just do small.
Oh.
Because this one
Does that
wasn't
make
there.
sense? I didn't say your name wrong. Free? What's up, Dante? Good morning, sunshine. How you doing? It's afternoon.
Oh, so it's both. Yeah.
What's up, Wes? Something with that seat today, like somebody put sleepy dust on it. And people are like, oh my gosh, so tired in that chair. Okay. I wanna hand back a bunch of papers to you guys, but can someone put up the answers, domain and range, for number 1, and someone put them up for number 2? This is a worksheet that you were given a couple days ago. That I collected, I thought, but I don't see them.
I think I got the first one and then the second one.
She gave it back? Oh, never mind, you already gave it back then.
Okay, I'm like so, I think it's for school there, like I'm already in school.
Yeah, it's hard, it's like everything like goes through that. You wanna play cooking with kind of fork? Can I play like fork?
What was the first game you do?
That's it, that'll bomb it. Alright, ready?
What'd you get? Wait, has it taken a second?
Alright, go.
Yeah.
Go, 3 on the
Alright guys, question. Do we agree with these answers?
Yeah.
Hold on. Okay, hello?
Bro. What is this?
Alright, guys, hello? Alright, Wes. Aiden. Hi. Okay. Your quiz on Friday does include these, and looking at what people put as answers yesterday on the worksheet that I did already also give back to you, there were issues. So, do you agree with number one? There's a break in it, but does every single X value have a Y value? Yes, it does. So the domain is all reals even though there's a break. And the range, well, there's a gap in the range right here, but it's filled in on this side, guys, shush. So I agree with this answer. Yes, Nora? No, I can't manage that. This guy, Raul, do you agree with their answer?
No. Yes.
Domain, is it all reals? Is there a Y value for every X? The range, negative infinity to square bracket 0. Does it hit 0?
Yes.
And all Y values below that? Yes. So, I agree. Can someone do these guys?
So these are. Like sewing. You seen that joke?
Pick one of the corners.
This is chess, so I take your X. Yeah, I take your X. This is chess.
It's the most. You're going here. I go here. This is Hey, Wes. Wait, I
Griffin, have a seat. Okay, hold on guys, there's some questions about the feedback card that you just got back. Also, this answer, negative infinity to infinity for domain, I agree. And the range, -6, square bracket, it's an island, it's all by itself. And then square bracket 0 to infinity, I agree. People were asking about the exit card, proving something's even or odd. The first test, is it even? So find f of -x. -x to the third minus -x minus 1. Don't leave it like that, clean it up. -x times -x times -x, there's 3 negatives, I end up with a negative. X the third, that exponent doesn't disappear. Negative x is positive, and that negative one stays. So the test, is it even, is, does f of negative x equal the regular old function? Positive x cubed in the original function, negative x cubed here, not equal, so not even. Okay. Is it odd? I need to check another thing. What's the other thing I need to do? Nor? Negative f of x. So that means negative to my original function. So I am going to distribute that negative sign inside to everybody in there. Negative x cubed plus x plus 1. The test to see if it's odd, does f of negative x equal negative f of x? All right, so let's look. Negative x cubed, that worked. But positive x, that worked. And then negative 1, positive 1, not equal. You needed to show that. And if you just made the right guess and said, well, it's neither, but didn't show the one to it, you don't get the credit. You need to show the support. Where did you do f of negative x? Where did you do negative f of x? You picked numbers. You didn't do x's, you picked numbers. Got a specific coordinate or something like that. I needed it for all of the numbers.
And we're thinking
Okay,
two different.
guys, hang on. This is my favorite example. So, this is true. 16 divided by 64 does reduce to be 1/4.
And you did the cross off the.
If you cross off the sixes, you're doing math that's full of crap and not real. Yeah, 16 over 64 is 1/4, but if you show me work that shows you don't understand what's going on, you don't get credit. Yeah.
Is there any sort of retake? Because I like,
Okay.
like, just 'cause, like, this didn't appear in any of my.
Alright, so